Hello, welcome to this video, dear students. Today we will see in this video what is a function in mathematics. So first we will see the definition of function and then see the types of functions, and we will see some examples of what is known as function. So first of all, you know that by definition we say f is a function from a set A to set B, when A, of course A should be a non-empty set and B also should be a non-empty set. So both are non-empty sets. So we say f is a function from set A to set B which obeys some rule. So we will see what are those rules which must be satisfied so that we can call this as a function. Now the first rule is every element of this set must have some image in the set B. Every element of this set, which is called domain of the function. So this set A is called domain of the function. Domain of the function, and this set is called codomain of the function. So there are only two rules which must be satisfied so that we can call this as a function. So the first rule is every element of set A should have an image in set B under the function f. So that means if you take an element x belongs to A, as I have already mentioned, A and B both are non-empty sets. So as I have already mentioned, both A and B are non-empty sets. Set A is called domain of the function A, function f, and B is called codomain of the function f. Now since A is a non-empty set, so there must be some element in A which should have, in fact every element of A should have an image in set B. So that means we say fx must belongs to B for all element x in A. Fx must belong to B. So whatever it may be, the set A is some set and set B some set. We will see examples what are those set possibly may be, but set A must be a non-empty set and B a non-empty set. For example, set of numbers, real numbers or any integers. So set A can be anything. So first rule is every element of A should have an image in set B. That is the first rule. So this is the first rule. Second rule is no two element So as I have already said, first rule is every element of domain set must have a image in the codomain set B. Now second rule is no element of A should have more than one image in set B. That means if every element of x, every element x belongs to A must have a unique image in B. Unique image. Okay. So every element, that means को गोटे भी एलिमेंट डोमेन सेट रे दीटारू गोटे रु अधिका इमेज हो पारिबोनी. सो गोटे एलिमेंट माने तार गोटे ही इमेज हो आ गोटे रु अधिका इमेज हो पारिबोनी. जदि ये दीटा कंडीशन सैटिस्फाई हुए ताहाले आमे कहिबा दिस इज ए फंक्शन फ्रॉम सेट ए टू सेट बी. So the rule of a given function can be different, but whatever the rules may be, it should satisfy these two conditions. Then only we call this as a function from domain set A to codomain set B. Now I am देखिबा some examples of functions. So very simple example is, suppose मैं कहिबी f is a function from set of real numbers to set of real numbers. That means here the domain set is R, the set of real numbers, and codomain set is also set of real numbers. So this is R is set of real numbers. So R is called set of real numbers. So आम जाने रियल नंबर्स कौन आम जाने नंबर लाइन रे आम देखो आम स्कूल रे भी पढ़ीचे नंबर लाइन आम केमती रियल नंबर्स रिप्रेजेंट हुए. सो गोटे नंबर रियल नंबर नबा x ताकू आम सपोज स्क्वायर करदवा. So this is a rule which will satisfy these two. कहीं ना आम एनी रियल नंबर नबा तार आम स्क्वायर करिपरिबा. So that means condition 1 is satisfied. Okay. अच्छा गोटे सेकेंड कंडीशन कौन ना गोटे रियल नंबर रो दीटा वैल्यू हो पारिबनी फंक्शन वैल्यू दीटा हो पारिबनी माने दीटा इमेज हो पारिबनी गोटे इनपुट रो एलिमेंट्स ऑफ डोमेन सेट्स आर कॉल्ड इनपुट टू द फंक्शंस एंड एलिमेंट्स ऑफ कोडोमेन सेट्स आर कॉल्ड आउटपुट ऑफ द फंक्शंस. सो फर्स्ट ए जो आम फंक्शन टा आम लिखिले x इज ए रियल नंबर एंड द इमेज इज x स्क्वायर. सो दिस इज क्लियरली So this rule clearly satisfies the first condition because any real number can have a square. Second condition भी satisfy होचे कहना गोटे रियल नंबर रो दीटा स्क्वायर हो पारिबनी. धर आम 2 नौचु x इज इक्वल टू 2 तार स्क्वायर होचे 4 अन्य किसी नंबर हो पारिबनी. सेमती एनी रियल नंबर नब धर आम गोटे रियल नंबर √2 नेलु. √2 इज ए इरेशनल नंबर बट इट्स ए रियल नंबर. सो √2 रो जदि आम स्क्वायर नबा ताले तार वैल्यू हबो 2. तो √2 रो स्क्वायर आगे हो पारिबनी. सो एनी रियल नंबर आम नबा तार स्क्वायर गोटे ही हबो आउ अधिका किछि हो पारिबनी. सो देयरफॉर सेकंड कंडीशन इज आल्सो सैटिस्फाइड. एवरी एलिमेंट ऑफ द डोमेन सेट मस्ट हैव ए यूनिक इमेज इन B. So this function, this is a rule which satisfies these two conditions. Hence we call this as a function. So we most of the time we write this function as fx is equal to x square. Fx is equal to x square. Okay. So this is also called parabolic or quadratic function. Okay. Now after we understand the definition of function, then we will see what are the types of functions, how differently we can classify functions. So, basically there are two types of functions, one is called injective function, another is called surjective function. So, injective function is what? So, function can be of two types, one is injective function, second is surjective function. So, which functions are called injective functions? So, definition is very simple. If you take any two input, let us say u and v are two inputs to the functions. So, there must be elements of the domain set A. So, if you take any two elements of the domain set, the image of u and image of v, if they are equal, then if fu is equal to fv, u, v are any two elements of domain set. If fu is equal to fv, then u must be equal to v. This is the condition of injective function. This is the condition of injective function. See, two different input can have same output, In general, two different input, one input cannot have different outputs, that is the condition of function, rule of function. One input cannot have two different outputs, but two different input can have one output in general. But if two inputs have one output, then the inputs must be equal. So, that means this condition says if u is equal to not v, then fu is not equal to not fv, also not equal to fv. So, this statement and this statement are actually equivalent. If fu is equal to fv, then u is equal to v. If you write the equivalent statement in the negative form, then u is equal to not v. If u is equal to not v, then fu is not equal to not v. Fu is not equal to not fv. So, this is the condition of either this condition or this condition, both are equivalent condition which must be satisfied in order for function to be called as injective function. That is the definition of injective function. So, in short, you can say two different inputs will have two different outputs. In general, it is not true, but for injective function it is true. Different inputs will have different outputs. Now, what is surjective function? Surjective function is every element. So, this is injective function. This condition must satisfy for injective function. So, what is surjective function? Surjective function is surjective function is every element of codomain set B, every element of B must have a pre-image in domain set A. every element, this is surjective condition, every element of B must have a pre-image in A. What it means? See, in general, the codomain set may be larger than the range of the function. So, what is, so we have seen this is called domain set, this is called, the set B is called codomain set. And what is called range of function? Range of a function, range of function is all possible outputs, set of all possible outputs. This is called range of the function. So, obviously range of function is a subset of B. So, obviously range of function is subset of codomain set B. But B can be larger than range F. In general, codomain set can be larger than range of the function. But if it is equal, then we say function is surjective. That means range of the function should be equal to the codomain function, codomain set of the function. Range of the function should be equal to codomain of the function. Range is all set of all possible outputs. Range of the function is set of all possible outputs. But if, so therefore it is a subset of codomain set. So if it is equal to codomain, subset can be equal or